In this video, we're going to take a look at section 2.5, which is on graphing linear equations. 2 points are the minimum number necessary to graph a line. So if we want to graph a line, we need to have 2 points to know where that line is located. That's the minimum number. Having 1 or 2 more isn't always a bad idea, but 2 is the minimum that you need. You can find 2 points by either finding 2 random solutions. This is the technique that we were using earlier in the chapter when we talked about graphing using the generic method. You just find a handful of solutions and they're kind of randomly found by picking a value for x, plugging it in, and solving for y. So that's one technique you could use and you can continue to use, but we're not going to cover that technique in this section because we already talked about it previously. A couple of new techniques that you can use to find 2 points is to find the x and y intercepts. So we're going to talk about that in section 2.5. And you can also get 2 points by using a point that you already know is on the line that you get from the equation, and then the slope to help you find a second point. And we'll talk about how that technique works as well. All right, so let's take a look at the intercept technique. So the x-intercept is the point where the graph crosses the x-axis. All right, so if I was going to sketch this up real quick. So if I have a Cartesian coordinate system here, I know it's not very well drawn, but say we have a line like this, the x-intercept would be this point right here. It's where the graph is crossing the x-axis. And the one thing we can know about that point without any other additional information is that the y-coordinate has to be 0, because on the x-axis, the y-coordinate is 0 for every point. That's why it's, because if the y-coordinate was a different number, you would go up or down. But because the y-coordinate is 0, that keeps you on the x-axis. So to find the x-intercept, you will set y equal to 0 in your equation, and then solve for x to find the x-coordinate that goes with the y-coordinate of 0, and that will give you a point that is on the x-axis. So that's how you find the x-intercept. The y-intercept is exactly the same idea, except x and y get switched around. So the y-intercept is the point where the graph crosses the y-axis. To find the y-intercept, you will set x equal to 0, and then you will solve for y. And the reason we're setting x equal to 0 is the same reasoning as we used last time. So if I have a line like this, here is the y-intercept for this line. This is where the graph is crossing the y-axis. This is the y-axis here. And the one thing we can know about every point on the y-axis is that the x-coordinate must be equal to 0. Right? And so if you want to find a point on the y-axis, you have to set x equal to 0 in order to do that. All right, and then you plug that into your equation, you solve for y to find the y-coordinate that corresponds to x equals 0, and that will give you a point that is on the y-axis. By finding the x-intercept and the y-intercept, you will have 2 points. And with 2 points, you can graph your line. So let's go ahead and practice using that technique here. So we have this equation. X plus 2y is equal to 4. So use the intercepts to graph this equation. So we'll start with the x-intercept. Step 1 is to set y equal to 0. So I'm still going to have x here. X plus 2 times, in place of y, I'm going to plug in 0. All right, so we're setting y equal to 0 here. And then step 2 is to solve for x. Now what's great about finding the intercepts is that you're plugging 0 in for one of the variables, and 0 is just a great number to plug in because it just makes things disappear. So here we're going to get 2 times 0, which is still 0. And then x plus 0 is just going to be x. And so really that term just goes away. Right? It just disappears. So I don't know how you want to write it. And you just get x by itself equals 4. So step 2, solve for x. It really just kind of does it by itself, right? When you plug in 0 there for y. And so that'll be my x-intercept. My y-intercept, the first step, is to set x equal to 0. So step 1, we will set x equal to 0. So we'll have, instead of x, we'll have 0 plus 2y equals 4. And then step 2 is to solve this for y. Now here the 0 just goes away, right? It just disappears. And we get 2y on the left-hand side equals 4. And y will have to do a little bit of work to solve for y. It's pretty easy to do, right? I mean, you know, this term just disappears, and the result you get is pretty easy to work with, where many students will just kind of work this out mentally, right? You just kind of imagine this term going away, and then all you have left is 2y equals 4. You divide by 2 on the other side, and you get y is equal to 2. And that's what we're going to do here. So we'll divide by 2 on both sides. We get that y is equal to 2, and that's my y-intercept. Now, it's very common for the x and the y-intercept to be described in the way that you see here. The x-intercept is 4, the y-intercept is 2. Mathematicians would describe it in this way. However, it's technically not the proper way of describing the x-intercept and the y-intercept. And there is a very real danger here that a lot of students come across, and a trap that they fall into is that they see this x over here on the left-hand side and this y over here on the right-hand side, and they think, well, x's and y's go together, so that means I have 4, 2. Right? I have this x and this y, that gives me the point 4, 2. And that is a mistake. That is totally incorrect. So this line does not have a point at 4, 2. This 4 for x does not pair with this 2 for y. The 4 for the x pairs with 0 for y, right? That's how we got x equals 4, by plugging in y equals 0. So the proper way to describe the x-intercept, and to avoid making that mistake of pairing it with the wrong number, is I should describe the x-intercept as 4, 0. Right? That's how I got x equals 4, by having y equal to 0. And that's what pairs together, and that way you're not tempted to pair it with the y-intercept, which would be incorrect. So maybe keep in mind as well that the x-intercept always has a y-coordinate of 0, and the y-intercept always has an x-coordinate of 0, right? And so here we plugged in 0 for x. That's what pairs with y equals 2, and so we get the point 0, 2. If Math Excel were to ask you to type in the x or the y-intercept, it would have to be typed in this way, as ordered pairs, not as just numbers. Okay. So we have these 2 points, 4, 0. So 4, 0 would be right here. 4 on the x-axis, 0 on the y-axis. And then 0, 2 would be this point here. 0 on the x-axis and 2 on the y-axis. And with those 2 points, we can graph our line. And so I'm going to do the best I can. This is kind of hard for me because I'm writing on a tablet. It's not the easiest thing to write with. And so I'm going to, I don't know. Let's see, is there a... Maybe there's a straight line tool here. Yeah, I think there is actually. Okay, here we go. I'll use this. This will make it perfectly straight. All right, so we're going to go from this point here. All right, perfect. All right. That way it's a straight line. Because if I tried to draw it freehand, it would be a mess. So, okay, so it should look something like that. So Math Excel will do that as well. So with Math Excel, you pick the line graphing tool, you plot the first point, and then when you go to plot the second point, the line's automatically drawn for you. On an exam, if you're doing the exam on paper, you'll want to have a straight edge to help you draw that line as straight as possible. So I often recommend my students use their ID cards. That's usually long enough, and so that should work. All right, so let's take a look at another example. Same problem, except a different equation. I gotta remember to switch back to the pen tool here. Okay, so we have 9y equals negative 45 plus 5x. The directions are the same. Find the intercepts, use them to graph. So here they've tried to scramble things up a little bit with the way the equation is set up, but really not going to cause us too much trouble with x and y intercepts. So let's do the x-intercept first. Step 1, we're going to set y equal to 0. So I'll have 9 times 0 equals negative 45 plus 5x. And then step 2 is to solve that for x. So 9 times 0, that's just going to go away. It's just going to equal 0. But because nothing is left on the left-hand side, we'll have to use 0 as a placeholder there. So we'll have 0 equals negative 45 plus 5x. And then we just solve for x from there by adding 45 to the other side. If we can. So you add 45. So we'll get 45 is equal to 5x. And then we'll divide by 5 on both sides. Sorry, it's kind of hard to see. But what you should end up getting is that x is equal to 9. For some reason, my pen just doesn't want to write for me today. Okay, so x is equal to 9. So my final answer for the x-intercept, so that I'm not tempted to pair it with the y-intercept, which would be incorrect, is that 9 gets paired with the x-coordinate, sorry, I said the wrong letter, x equals 9 gets paired with the y-coordinate of 0. And so my point here that I should write is 9, 0. Right, x always goes first, y always goes second. All right, so that's one point. Let's go ahead and find the y-intercept. Step 1, we will set x equal to 0. So we will have 9y equals negative 45 plus 5 times 0. So that 5 times 0, that just goes away, right? That's just equal to 0. But then 0 plus negative 45 is still going to be negative 45. So that term just disappears. And now to solve this for y, we just divide by 9 on both sides. And we get y is equal to negative 5. That negative 5 pairs with x equals 0. So my ordered pair is going to be 0, negative 5. And that would be my y-intercept. So we'll plot these 2 points. We have 9, 0, which will be way over here, right? 9 on the x-axis, 0 on the y-axis. And then 0, negative 5. 0 on the x, negative 5 on the y. So there's my 2 points. And with those 2 points, I can draw the graph. So and there should be a straight line connecting those 2 points. All right, so that's the graph of that line. All right, so let's take a look at the next topic. There's actually quite a few topics in here, so I apologize. This section is we have several. I've kind of mentioned we're going to talk about slope and intercepts for graphing, but then there's vertical and horizontal lines, and there's parallel and perpendicular lines. And all of that is in section 2.5. So we have quite a few more things to talk about. So to use the slope to graph a line, the slope is like a treasure map that tells you how to find a second point. So to use the slope to find a second point, start from a point that you already know is on the line. We will talk about how to get that information as easily as possible. Then use the slope as a set of directions. Like I said, it's like a treasure map. It's giving you a set of directions to find a second point, to find another point. Remember, the slope we talked about in section 2.4 is the rise over the run. The rise is the vertical change in the line. The run is the horizontal change in the line. So the directions you're getting from the slope, the top number, the numerator, tells us how far up or down to go from the point that we already know is on the line. That's the vertical change, how far up or down we should go. And the run, the bottom number, the denominator, tells us how far to the left or right we should go. And if we follow those two sets of directions, how far up or down, and then how far left or right, wherever we end up is another point on the line. So we can go ahead and bubble it in. All right, so the slope will give us directions for finding that second point. The only thing that's necessary is that we need to know where to start from. We need a point that we already know is on the line to begin with. So this always brings to mind for me Indiana Jones and the Last Crusade. It's kind of an old movie at this point, but if you've seen it, Indiana Jones' dad is trying to find the Holy Grail, and he has all the directions. He knows exactly what to do to find it, except he doesn't know where to start. And so that's the thing with graphing these lines. So the slope is like Indiana Jones's dad's Grail diary. It has all the directions for how to find what you're looking for, but you need to know where to start from. And so we'll talk about how to find a starting point here when we do this example. So here they're exercising the use of function notation. Whoops, sorry, I forgot. I need to go back to the pen tool again. Okay, f of x equals negative 10/3 x minus 6. So there's going to be so few opportunities in this course to use the function notation that whenever the opportunity presents itself, the textbook takes advantage of it. We're not going to see the function notation again for quite a while after this chapter, but just remember f of x is just the y variable. This is just y equals negative 10/3 x minus 6. And this equation is in slope-intercept form. And we talked about slope-intercept form in the previous section in 2.4. And we can line up the variables and we can line up the constants to figure out some information about this equation. So we can see here that we line up the y's, we line up the x's. What lines up with m is the number negative 10/3, right? So m is equal to negative 10 thirds. That's my slope. I just get that for free. I just read it straight off the equation. So I already have the slope, which again is my set of directions. The top number tells me the rise. It tells me how far up or down. It's very common. Now you can see up here the way it's typed out, the negative sign's really neutrally in front of the fraction. But I think the most common thing that students like to do with that is to associate it with the top number. And you can see I've really done that here. So I've put the negative sign with the 10. You could put the negative sign with the 3. It's fine. You could put it with either number, not both. You have to choose. So where do I want to put that negative sign? You have to either associate it with the top number or with the bottom number because it needs to be taken into account at some point. So I think the most common thing that most people do is put it with the top number. So the rise here is negative 10, which tells me as a set of directions that I want to go down 10 because it's negative. If it was positive 10, we would go up 10. The bottom number of the slope is 3. That's the run. That's telling me the horizontal change. It's a positive 3. So that means I want to go to the right 3. So we have this treasure map that tells us if you go down 10 and to the right 3, you'll find what you're looking for. But we need to know, we have to have a starting point to apply those directions. We need to know where to start from. And you can start from any point you want that you know is already on the line. And so the easiest point for us to find that we know is already on the line is the y-intercept. Right? Because that also is just given to us in the equation. It requires no work whatsoever. You can just read it straight off the equation, right? B is equal to negative 6, which tells me that the y-intercept is at 0, negative 6. Let me rewrite that again real quick. Okay, so 0, negative 6. That's a point that I know is definitely on this particular line. And so from that point, I can apply this set of directions to find a second point that will be on the line. So I'm going to start with this point, 0, negative 6. Now be careful, they kind of changed the numbering on this graph. It's going by 2's. So this is negative 2, negative 4. This is negative 6 right here. And from here, I'm going to go down 10 and to the right 3. So starting from this point, we will go down 10. That's negative 10. We're at negative 6, so going down 10 gets me to negative 16. And then from there, we want to go to the right 3, positive 3. Now remember, this is going by 2's, so don't go 1, 2, 3 and put the point here because that would be at 6. We want to go over just 3, which would be halfway between 2 and 4, which is where I tried to stop, so about right here. Right, so it's going from this point down 10 to negative 16, and then to the right 3. And wherever we end up is another point on the line, so I go ahead and bubble it in. Right, so now we have 2 points. The one we started with, the one we were given for free from the equation, and then the one that we worked for by applying the slope to help us find it. All right, so from there, we will graph our line. So I use the line drawing tool here. So let's see if I can do this. Okay, so connect the 2 points with a straight line. And again, it goes in both directions. So on the test, when you do the test on paper, sometimes I'll have students that just connect between the 2 points, and I sometimes will count, how do I want to say that? I will take points off if the student only draws the line between the 2 points, because the line doesn't just stop there. It goes forever up and to the left and forever down and to the right. So it doesn't just go between the 2 points, but it goes beyond that as well. All right, let's take a look at another example. So same question, find the slope and the y-intercept to help you graph this equation, which is actually kind of the hard way to do this problem. The easy way to do this problem would be just to find the x and y intercepts. But we've already done that, so let's talk about how you would do it this way with this new technique using the slope. The reason it's more difficult is because if the equation's in standard form, which is what we have here, you can't just see the slope and the y-intercept. You don't get that information for free. You can't just read it straight off the equation. You have to rewrite this equation in slope-intercept form. So I will have to rewrite it as y equals mx plus b. We talked about doing this previously in section 2.4, so it's just more practice doing that. In order to get it into that form, that means get y by itself. Solve it for y. So I will subtract 2x to the other side. I'll get negative 5y is equal to 10 minus 2x. And then I divide by negative 5 on both sides. So I will get y equals, and remember the processing that we had to do over here on the right hand side to get it to fit better into the formula. You take the -5, you divide it into both of these terms individually. So you get 10 over -5 minus 2x over -5. So I'll write the final answer over here. We get y equals 10 divided by -5, works out to just be -2. The double negative minus the negative fraction will make this positive. We'll put the 2/5 first, and then we write the x to the side of the fraction. So that's how we process that right-hand side to get it to fit into the formula better. And then we can more easily see the slope and the y-intercept. Remember, the slope is the number in front of x. So in this case, the slope is 2/5, and the y-intercept is at 0, -2. Right? So the y-intercept is this. All right, so we have the slope, we have a point, so we have a starting point, right? We have 0, -2. It's this point right here. And then from there, the slope tells me a set of directions to find another point. The set of directions this slope is giving me is the top number is +2, so I will go up 2. The bottom number is +5, so I will go to the right 5. Right, so that's the set of directions I will follow, and by following that set of directions, I will find a second point. Starting from 0, -2, I'm going to go up 2, and then to the right 5. And I end up here at this point, at 5, 0. And then we connect the 2 points with a straight line. And that'll be our graph. We can get that right there. Okay. All right. And so that's how you graph using the slope. All right. Let's take a look at another topic here. Vertical and horizontal lines. So vertical lines have an undefined slope and are described by equations of the form x equals a number. So even though these are lines, the equations do not have two variables. They only have one variable. That's kind of what makes them special exceptions that we have to spend some extra time talking about. Right? So if your equation is just x equals 5, that will graph as a vertical line. And the slope for that line is undefined. It's because remember, slope is measuring how steep the line is. And if you have a vertical line, let's try that again. If you have a vertical line like this, how steep is that line? Well, it's infinitely steep. It's just a complete straight drop. And so the slope can't handle that. So it's an undefined slope because of how steep it is. It's just infinitely steep. Horizontal lines have a slope of 0. So if you think of a horizontal line, right, it looks like this, it's flat. So the slope is going to be 0 because, again, the slope is measuring how steep that line is. A flat line is not steep at all, right? And so it has a slope of 0. And these equations are described, how do I want to say this? These lines, that's what I should have said. These lines are described by equations of the form y equals a number. So if you have like y equals -2, that will just be a horizontal line. So that is how vertical and horizontal lines work. Let's take a look at a couple of examples. We have here x equals 5. So if it's x equals a number, this will be a vertical line. So I'm going to write that out. Now I want to graph this vertical line, and the vertical line I'm looking for are all the points that have an x-coordinate of 5. And what a lot of students will do first is they will find 5 on the x-axis, right? We have x equals 5, so they find 5 on the x-axis and they mark that point there. That's one point that's on the line. On the exam, I will have students that's all they do. They mark x equals 5 on the x-axis, and then they move on to the next problem. But that is not the complete graph. I'm looking for the entire line of all the points that have an x-coordinate of 5. So not just this point, but all the points with an x-coordinate of 5. And that would be all the ones above and below this point as well. So for example, this, right? This point here has an x-coordinate of 5. It's 5, 2. This point down here has an x-coordinate of 5. It's 5, -6. So you want this entire vertical line of points here. So let's see if I can graph that. When you're doing this on Math Excel, you need 2 points to graph a line, as we talked about earlier. So you need to mark 2 points in order for Math Excel to draw the line for you. So you can start with 5 on the x-axis, but then you need to pick another point with an x-coordinate of 5 for Math Excel to draw the line for you. All right, So I'm going to try to make this as vertical as I can. Let's see. Okay, that's pretty good. And then we'll go up this way, vertical as well. All right, oh, that came out pretty good. All right, so that would be our graph for this equation, x equals 5. It's that vertical line right there. And if it asks you, oh, it does ask you actually. It's not on the screen, but it does ask, if possible, determine the slope. And it's going to give you two choices. It's going to say the slope is equal to blank. That's option A. Option B will be the slope is undefined. And this time we want to use option B. The slope is undefined. It cannot be determined because it's a vertical line. It's infinitely steep. All right. So for vertical lines, slope is undefined. Okay. For y equals -2, so I actually happened to give this example earlier, so I didn't realize that would be the actual number that we're going to encounter. So for y equals -2, this equation has a form of a horizontal line. So horizontal line. All right. And so this will be all the points that have a y-coordinate of -2. And just like in the last example, many students will say, well, here's -2 on the y-axis. I'll just plot that point, and that'll be my graph. But that's not the graph we're looking for. We're looking for all of the points with a y-coordinate of -2, not just the one on the y-axis. So for example, this point, right? This is at 4, -2. It also has a y-coordinate of -2. So it also belongs on my graph. This point here, -3, -2, has the y-coordinate of -2. So you see you get an entire horizontal line of points that have this particular y-coordinate. And so the graph will be a horizontal line. So let's go ahead and try to draw that, connecting these points here. And same thing as I mentioned on the last example, to get Math Excel to draw this line for you, you have to have 2 points. So it's fine to start with this point here at -2 on the y-axis, but then you need to pick a second point with another y-coordinate of -2 to get Math Excel to draw the line for you. This time, the slope, whoops, thought I switched it, but I guess I didn't. This time, the slope is 0. So when I ask you for the slope, you choose option A. The slope is blank, and you type 0 into the box, because the slope will be 0 for a horizontal line. All right, so in this case, the slope can be determined, and it's equal to 0. All right, so the last topic of this video, parallel and perpendicular lines. So 2 lines are parallel if they never intersect. And for them to never intersect, the lines have to be slanted exactly the same. All right, so if you have one line that's slanted a little bit more than the other line, they're eventually going to cross each other, so they're not parallel. For them to be parallel, the lines have to be slanted exactly at the same angle, and since the slope is measuring how slanted they are, the steepness of the line, for lines to be parallel, to be slanted the same, the slopes would have to be equal to each other. So parallel lines have slopes that are equal. That's how you know they're parallel. So it works both directions. If the lines are parallel, the slopes will be equal, and if the slopes of 2 lines are equal, they will be parallel. 2 lines are perpendicular if they intersect, but not just if they intersect. That's not special enough, right? If they intersect like this, that just means they're not parallel. What's special about perpendicular lines is that they intersect at a 90-degree angle. So these 2 lines would not be perpendicular. They're not intersecting at a 90-degree angle. It'd have to look like this. Right? That's kind of a bad example, but hopefully you get the idea. Right? A vertical line and a horizontal line intersect at a 90-degree angle, so they would be perpendicular. So the x-axis and the y-axis are perpendicular to each other. Perpendicular lines have a really interesting relationship with the slopes. The slopes are negative reciprocals of one another. So negative reciprocal is a way of describing a relationship like this. Negative means they're opposite sign. Reciprocal means they are flipped over versions of one another. So for example, if I have 2/3, the negative reciprocal of that, I would need to take the reciprocal, which would be 3/2, but the negative of that would mean opposite sign, so I get -3/2. So these numbers are negative reciprocals of each other. They're opposite sign, and they are flipped over versions of one another. Right? 2/3 versus 3/2. So if you have 2 lines with these two slopes, those lines will be perpendicular. They will cross each other at a 90-degree angle. All right, so in this section, you're going to be asked, given two lines, are they perpendicular or are they parallel? And to determine the correct answer, you will want to look at the slopes of those two lines. If the slopes are the same, if they're equal to each other, then you'll say, yes, these lines are parallel. If the slopes are not the same, you'll say, no, they're not parallel. And if the slopes are negative reciprocals of one another, like we see here, you'll say, yes, these lines are perpendicular. If they are not negative reciprocals, you'll say, no, they're not perpendicular. So that's what we're going to be doing for these next few problems. Now, I really don't like the structure of these problems because I would like everything to be on the table. I wish these problems said, are these parallel, perpendicular, or neither? But that's not the way this textbook has these problems set up. So you kind of look out there. So it's just a yes or no question. In this case, are they parallel or are they not? Either it's yes, they're parallel, or no, they're not parallel. To determine whether these lines would be parallel, you could set up a graph and eyeball it, but that's not 100% trustworthy either. Because what if one line is just slightly more slanted than the other? Your eyeball might not notice that. And what if you don't draw your graph the best possible, right? I mean, if your graph is not the best drawn graph, then they might look like they would intersect when really they wouldn't. And so the best way to determine if two lines are parallel is to look at the slopes of those two lines. So in order to do that, let's start with the first line here. We have x plus 8 equals y. To find the slope of this line, we will use the slope-intercept form, which it already is in. It's just written backwards. I'm going to flip this around, put y on the left-hand side, x plus 8 on the right-hand side. It's already in slope-intercept form, right, which is y equals mx plus b. And I don't even care about b in this problem. All I care about is the slope. And this one's, we haven't seen an example of this yet, I don't think. So there's no number here in front of the x, which means it's an invisible 1. And so the slope is equal to 1 in this case. So the slope of the first line is equal to 1. In order for these lines to be parallel, the slope of the second line would also need to equal 1. So let's take a look at the second line. We have y minus x equals negative 4. This equation is not in slope-intercept form. We need to solve it for y to get it in slope-intercept form. So I will add the x to the other side, and I'll get y equals negative 4 plus x. Now this is in slope-intercept form. The slope for this line is the number in front of x, which is also a 1. And so these two lines have the same slope. So these slopes are equal, which tells me that yes, these lines are parallel. So you compare the two slopes. If they're the same, yes, the lines are parallel. So let's see, what are they asking me to do here? The slope of the line. So they're going to make you answer for the slope for each line first, and then your conclusion last. So the slope of the first line was equal to 1. So you type 1 into this box. It'll ask you what's the slope of the second line. You'll type in 1 for that. And then it'll say, are these lines parallel, yes or no? And you will say, yes, they are parallel. So they're going to kind of make you type in a lot of information here. But they want to make sure you're doing it the right way. Finding the slope of the two lines first, and then concluding from that they're parallel. All right, let's take a look at another example. We want to know, are these two lines perpendicular? Now this one, they just jump right to it, right? Are they perpendicular, yes or no? So we will do the same thing. We want to look at the slopes of these two lines to make that determination. So the slope of the first line, well, this is already in slope-intercept form, y equals mx plus b. And I can see from lining those up, the equation with the formula, that the slope is equal to 3. So the slope of the first line is equal to 3. What is the slope of the second line? Well, we'll have to do a little bit of work to find out because it's not quite in slope-intercept form, but it's pretty close. We just need to get rid of the 2 here. Get y by itself, divide by 2 on both sides. We get y is equal to 7/2 minus, now this one's a little bit tricky. So what I'm doing here is I'm taking the 2, dividing into each one separately, get the minus sign here, and then x over 2, I'm going to put the x to the side of the fraction. The 2 will stay on the bottom, and what will stay on top is a number that you don't actually even see here, but it's, again, it's an invisible 1. Right, we have 1x here, and so that 1 will be on top. So we get 1/2 x is the way you want to write that. All right, so maybe I should write that out in a little more detail. So we have 7 over 2 minus x over 2, but think of this as 1x. Put the x to the side of the fraction, and that's how you get this. The slope here is negative 1/2. So are these parallel? No. The slopes are not the same, so they're not parallel. I know that's not what they're asking us, but I just want to emphasize that point again. So these are not parallel, right? They're not equal. All right, so they're not parallel, because you might have some homework problems that say, are these lines parallel? Sorry, I put an extra line there. Are these lines parallel? And if it worked out like this, you would say, no, these are not parallel. Are they perpendicular? Well, to be perpendicular, they'd have to be negative reciprocals of one another. So what is the negative reciprocal of 3? So we have 3 as one of our slopes. Think of that as 3 over 1. The negative reciprocal of that would be, waiting a moment for you to think about it, right? You flip it over, so it'd be 1/3. That's the reciprocal part. And then it should be the negative of that, which means opposite sign, so it would be -3. So this is what negative reciprocals would look like. I have negative 1/2, not negative 1/3. So these slopes are not negative reciprocals of each other. The negative reciprocal of 3 would be negative 1 over 3, which is not what my other slope is. So these are not perpendicular. Right? So these are not, let's see, maybe I should write it out in a little more detail up here. 3 and negative 1/2 are not negative reciprocals. I'm going to abbreviate that, if that's okay with you. And so these are not perpendicular. Hope that's okay if I abbreviate. Okay. So these are not perpendicular, so the answer in this case is no. All right, so I hope that's clear how you determine if they're perpendicular. There's actually a pretty quick test to determine if they're perpendicular that I didn't mention, but if you multiply them together, it should equal -1. So if I take 3 times negative 1/2, I'll get -3/2, which doesn't equal -1, and so they're not perpendicular. So that's a quicker way to tell. If they're negative reciprocals, when you multiply them together, the answer will always be -1. And if I multiply these two together, I don't get -1. So they're not perpendicular. One more example here. So why don't you guys try this one real quick if you haven't already been doing that as you've watched this video. Pause the video for a moment and then determine if these two lines are perpendicular by finding the slope of each line. So I'm not going to give you a minute. You take as long as you need. Pause the video, take as long as you need, then resume the video and you can check your answer to see if you have the right answer. All right, so what you should be getting here is x plus 2y equals 5. Right, that's the first equation. We have to get that in slope-intercept form. We have to write both of these equations in the form y equals mx plus b in order to get the slope. So we're going to solve each of them for y. We'll subtract x from both sides. We get 2y is equal to 5 minus x. Then we divide by 2 on both sides, and we will get y equals, let's try that again, 5 over 2, and we already saw this situation in the previous example. This will be -1/2 x, right? Because the 2 is going to divide into both of these, and then we write the x to the side. There's an invisible 1 in front of that x, and so this is how you get -1/2 x, just like we talked about in the previous example. So the slope here is -1/2. Now it might be a good idea before you look at the second equation to think about what would you need to see as the slope of the second equation for them to be perpendicular. The negative reciprocal of -1/2, I would flip it over, so I get 2 over 1, and take the negative of this, which means take the opposite sign. This one's already negative. The negative of a negative would make it positive, so it'll be positive 2 over 1, which is 2. So in order for these lines to be perpendicular, the slope I need to see for the second line is a slope of 2. So let's see if that's what we get. All right, so we have 2x plus 4y equals 9. We have to solve this for y to find the slope. So I'll subtract 2x from both sides. I'll get 4y is equal to 9 minus 2x. And then we divide by 4 on both sides. Everything gets divided by 4. And we get y equals, we get 9 over 4 sorry, I don't know why it's not writing for me. 9 over 4 minus 2 over 4x, which can be reduced, and maybe you did that already, and that's good if you did. You get 9 over 4 minus 1/2 x. So the slope we get here is negative 1/2. Again, right? Just like we had over here. So are these lines perpendicular? No, because I needed to see a slope of 2 for them to be perpendicular. But they're parallel, right? The slopes are the same. So these actually, not that it's asking this, but just to point it out, these lines are actually parallel to each other. All right. They're not perpendicular. They're parallel this time. Sorry, I don't know why it's not writing for me. Okay. So that is the end of section 2.5 on graphing linear equations.